Hello guys, welcome back. I want to apologize for a couple of things. One is the lack of new tutorials in a while. I've just been very busy and a bit lazy as well, and doing a bunch of other stuff unrelated to computers. And the other one is the sound that you're hearing, which is my son is listening to some baby cartoons, so I apologize for that. So today I thought about doing something a little bit different. Instead of Unreal Engine 4, I decided to give a try to the Godot engine, which is basically another 3D engine like Unity and Unreal. This one is developed by Juan Linietsky. I hope I'm pronouncing that right. Ariel Manzour and a bunch of other contributors. It's basically an open source 3D engine, so if you use it, you don't really have to pay anything to anyone, unlike Unreal and Unity. Even though, of course, donations are appreciated from these guys, I'm pretty sure. So I would describe Godot or Godot, depending on how you want to pronounce it, like maybe an hybrid between Unreal and Unity. I feel like the scripting is a bit maybe more powerful than Unity in a way. Not as powerful as Unreal, as you can do whatever you want in Unreal in C++, which gives you tons of flexibility. But this one seems like a really promising engine. I'm liking it so far. I'm following a Udemy course on it, which is pretty good. You should check it out. You do a bunch of games and learn about the engine in the process. So basically, I wanted to try to do like a kind of a sphere made of cubes, like a spherical Minecraft, if you will, maybe in the future. So let's see if this becomes a series or if I'm just gonna do this one example. So let's start by, this is the main window of Godot. It's basically the project manager, where you're similar to Unreal and Unity as well. So let's do a new project. Let's I'm gonna put it in this folder. I'm just gonna call it maybe Spherical Minecraft, which is kind of a wishful project name. You have to create folder. Oh yeah, I have another folder. Let's create. Let's go with tutorial. So it creates the folder, then you get the green check, and then you can finally create and edit. You can choose the OpenGL ES3 or ES2 depending on your hardware requirements. We'll just go with 3 because I'm running this on a desktop. I don't really care about hardware. And basically, the Godot engine will load. You'll be greeted with the 3D view. You can also do like a 2D game if you want. It's actually very, very powerful, the 2D tools. I haven't explored a lot in 3D yet. And then you have like the script view up here, where you can see all the scripts that you have for. It also has an embedded editor for scripting, which is also pretty cool. So okay, I want to show off one of the features that they have here in 3D, which is the multi-mesh instance. And it's basically okay, let's just put a spatial node here so we can basically put the other one in hierarchy as a child. And let's bring in a multi-mesh instance. The multi-mesh instance is basically an object in Godot that can instantiate multiple meshes and do this like in just one rendering call. So it's really inexpensive. You can replicate a gazillion of objects basically. As long as they're all the same mesh, you can just replicate all of them. And it's very inexpensive. So on the right here you have the inspector, like similar to Unity, more similar to Unity than Unreal, I would say. And you can see the properties of the multi-mesh instance. We could create a new multi-mesh, but I'm not going to do this on the editor. I'm going to do this in code, which gives me more flexibility. So I'll just go to attach script to the multi-mesh instance, and I'll just create a new script called multi-mesh instance, let's say. And you can pick a couple of languages that you can write the scripts in. You can do Visual Script, Native Script, and GDScript. GDScript is Godot script. It's similar to Python. It's a kind of a nice language if you like the syntax and if you like your code indented basically by design. It's pretty structured. So similarly to Unreal, your scripts will inherit from something, and they will have a few functions that are part of the engine, or the engine knows that if you have these functions you need to call them, like on ready, this is called whenever the game starts. You have others like input and process for every frame, basically very similar to Unity in a way. I'm just going to get rid of all of this because I don't really need it. Instead, I am going to take advantage of something that the engine allows us to do, which is to expose properties on the engine interface as well when you're doing things visually instead of by code. So let's just export a var called cubes per side, and let's say 16, and I'm going to define a setGet function which gets called even by the editor whenever this variable changes, and you'll see what I mean in just a second. So I need to define this function, and the way you define functions is with the keyword func, and then I'll just call it set cubes per size, and I accept a new value for this cubes per size, and then I do cubes per size equals the new cubes per size, and I'm just going to save it. Actually, I'm going to save the scene. The scene by default takes the name of the root element in the scene, so I'll just name it special. I don't really care right now. I think I have a typo here somewhere, maybe. Setter function is not defined. Set cubes per side. Oh, per side. Nice. And per side. My bad. Cubes per side. I can't type today for the life of me. Okay, so basically if we go back to the 3D view and we select the multi-mesh instance, you can see the cubes per size here, and whenever I do this, if I look at the output, this setter is actually being called whenever I change this variable. Cool. So this is just a way for me to be able to generate like an entire array of cubes, first in a cube and then later in a sphere, and I can see it immediately on the editor. I don't need to play the game to actually see the results. So going back to the script, what do I want to do? Let's say whenever I change this value, I want to update. And update is going to be one of my functions. And let's see, what do I want to do in update? First thing I want to do is like, you can hear my my son singing along. I'm sorry about that. So first I want to update the multi-mesh, or set up the multi-mesh. I'll just set up the object itself here, and then I will call generate sphere, which actually is going to generate a cube. For now, a cube of cubes, but later we'll make it into a sphere. So setup multi-mesh is going to be a function that let's see, first we'll do self.multimesh, which is our multi-mesh instance here. The reason I'm doing self multi-mesh, and for those of you who know the Godot engine, and I'm not doing this, which is an in-game reference to this multi-mesh node here, is because this is only allowed, I think, when you're running the game. But if I do self.multimesh, I'm actually referencing what I have right now, so it works in the editor as well. So basically I'm going to do multimesh.new. I'm going to instantiate a new multimesh to myself multimesh, and then I am going to do another couple of things that need to be done according to the docs. I will do transform format equals multimesh dot a transform 3D. So I'm saying that this multi-mesh is going to instantiate a 3D object, or it's going to work in 3D space. At least that's what I'm guessing this does. Then I am going to define how many instances of the mesh I want for this multi-mesh, and the instances are very easy. It's going to be instance, so this, you define it as instance count, and it's going to be cubes per side times cubes per size times cubes per side. Per side, I cannot type today. What's wrong with me? Okay, so we have 3 faces for the cube. We have so 16 times 16 times 16 as the instance count. And then I also need to do like self.multimesh.visible instance count, because I need to tell how many of those instances are visible. You can have multiple, but only few of them are visible. And I'm just going to set it equal to the instance count itself. Now, I need to tell the multi-mesh which mesh to use. So I'm going to create a mesh. Let's create a default cube mesh, which is a primitive in Godot. And I'm going to say that the mesh.size equals vector 3, 1, 1, 1, because the default, I believe, is 2. And I want a smaller cube in this case. Later I'm going to set up a material and put a little color, just a random color, so we can more easily see things. But for now, let's just do self.multimesh.mesh equals mesh, and that's it for our update function. Now I need to generate the actual sphere. In our case, it's going to just be a cube for now, but let's call it generate sphere for future sakes. And what do I need to do here? I want to, for some reason, I'm not sure I can access the size of the cube inside the mesh, so I'll just define a cube size. There's room for improvement in this script for sure. Let's just go with this, and I also want to define the cube half size. It's just for simplicity's sake. It's going to be cube size slash 2.0 divided by 2.0. Be sure to make this a float, because if you do it by 2, just by 2, it's going to do an integer division, if I'm not mistaken, instead of a float division, and we want a float division. So I also want to calculate the distance to the origin, because I don't want to start drawing at 0, 0, 0. I want to start drawing in at minus half of the size of the cube, just so the cube is finally centered at 0, 0, 0. So I need to do some calculations for that. And this is just going to be cube cubes per side times cube size divided by 2, or in this case cube half size. Actually, I just realized I had a typo in my reference, minus cube half size. So I want to decrease also the half of the size of the cube, just so you go back that little distance. This will make sense in a while. And I want to specify the origin. The origin is going to be minus vector 3 of origin distance, origin distance, origin distance. This is our origin. And I also want to define an index, because I need to reference the instances inside of the multi-mesh instance, and that's the way we do it. So I'm just going to do a for loop for x in range, and this range is going to be cubes per side, and I'm going to repeat this for y and z or z as well. And here I have to calculate the position of this cube. It's going to be the origin plus a vector 3 of x times cube size, y times cube size, and z times cube size. Right? Knowing the position, I also want to, well, I don't want to. When we're calculating a sphere, we'll do a little trick, but for now, we are just going to do self.multimesh.set instance transform, and we want to set the instance with index to a new transform of bases, I haven't read this yet, but I think basis is basically the rotation. So the transform is composed of the rotation and the position. Basis could also include scaling. I'm not sure. I haven't read it yet, but this seems to work. So I set the instance transform, basically the position in a nutshell, and then I do index plus equals 1 because I want to increment the index, and I save my script. I go back to the 3D view, and nothing happens because generate sphere is not declared in the current class. And I have a typo somewhere. No, that's not it. Method failed, return error, parse error. Let me just clear this real quick. Okay, let's change to 17. And nothing is happening. Okay. Clearly the set cubes per side is being called, but the multi-mesh is not being generated. So what's wrong here? Okay guys, welcome back. I just realized what I missed, and it was very simple. I forgot to declare this script as a tool, and this is actually the keyword that tells Godot that the editor can use this to generate stuff. Basically, it can be used as a tool inside the editor. So as soon as I put tool in here, we can see that it's generating our cube, and I can decrease the number of cubes per side until 1. And I can increase it further to what I want. Basically, this is basically a composition of cubes. So let's try to visualize that in a better way. And we can do that by adding some color. I will just do self.multimesh.color format. This needs to be set up to tell which type of color to use on the multi-mesh, and we can use color 8-bit, for instance. And let's see, what else do I need? I need to set up a new material for this, and I'm just going to call it material equals a new spatial material. I'm just going to give it a vertex color, basically. So spatial material new, and then material dot vertex color uses albedo equals true. And let's just do mesh dot material equals material. And now we need to give it a color to each of the instances. So we'll just go, let's see, when we do the instance transform, we can also do self.multimesh.set instance color. And we can just do index color, and I need to create this color. This color is going to be, let's put it, let's say here, var color equals color, and let's just generate a random float between 0 and 1. Rand float, and there's another thing we need to do. We should actually randomize every time we update, just so we generate new random numbers every time. So if I save this and go back to my cube, you can see that the cube is actually made of a ton of tiny cubes, and we can just decrease the size or increase the size. So now let's make it a sphere. How do we make it a sphere? Well, the easiest way is just to test against the distance to the origin, and if it's more than a certain distance, in this case the radius of the sphere that we want to create, we just don't show those instances. Otherwise we do show them. So let's set up another variable for the editor called radius, and let's make it 8 by default. Let's also generate the set get called set radius, and I'm going to basically do the same that I'm doing for the set cubes per side. I'm just going to go with set radius, new radius, and radius equals new radius, and I also update whenever I change the radius, right? And since we now have the radius, if we go back to the interface, here it is. It just generates. You can see by the random colors changing that it's actually generating every time I change it. And now I'll just use this information to decide which cubes to draw. And this is the really easy part. So the only thing I need to do is, I already have the position. I just calculate the distance to 0, or to the origin, you could call it that. We just do pos or position.distance to vector 3.0. I want to know the distance to the origin, and if distance to 0, if distance to 0 is less than radius, I want to do all of this. Otherwise, I don't. And this should, in principle, generate the sphere. There you go. And you can play around with the number of cubes per size. If you want something a little bit more flat, you should just increase the radius, and then you get more of a rounded cube of likes. And if you go to the exact half, then you should have a perfect perfect sphere. I'm sorry. So you could also now also optimize this. Since this is all drawn in one rendering pass, there's not really a big bonus in doing so, but you could potentially also test for the distance being less than something, and then you wouldn't draw all the cubes inside of the sphere. But like I said, it's all drawn in one rendering pass, so there's really not big of a deal. Also the same, you could basically decide the number of instance count here instead of just being the full blunt number of cubes times number of cubes times number of cubes. You could also do these calculations and figure out what the actual instance count is of the number of meshes that you're going to use inside the multi-mesh. But like I said, it's small optimizations that probably are not worth it. So yeah, I'm gonna leave it at that for this first one, and I don't know, I might do on the next one, I might do like something with physics, maybe put some colliders on this. I don't know if it does it by default. I'll try to figure it out, and then eventually move on to the point where we could have like maybe spherical gravity here. So instead of gravity just pulling down on the y-axis, it would pull towards the center of the sphere, and then that means that if you can have your character keep an upright position depending in relation to the sphere, you could potentially walk around the sphere and treat it as a normal terrain, but this time like a spherical terrain. And that would be really cool, because if you increase the number of cubes per size and the size of the radius, you could have potentially a very big world here, fully destructible like Minecraft, and you could walk around on a Minecraft planet. So that's it for this one, guys. I hope you liked it, and I'll see you in the next one.